where the sun didn't just shine, it ruled with a vengeance. Imagine it. 120 degrees Fahrenheit, the air so dry it cracks your skin, and no electricity, no fans, no ice to ease the suffering. The stone palaces of the time were like ovens, baking anyone inside. Yet, the people of ancient Persia didn't just survive this brutal heat. They thrived. How? They built something extraordinary. A cooling system that could drop temperatures by 40 degrees Fahrenheit, using nothing but wind, water, and a brilliant understanding of physics. This is the story of the Persian air cooler, a marvel of ingenuity that's as relevant today as it was 800 years ago. And here's the kicker, you can build one yourself. So, grab a seat, maybe a cold drink, and let's travel back to a time when survival demanded genius. Picture yourself in Baghdad, 1200 AD. The Tigris River glitters under a relentless sun, but its banks offer no respite. The heat presses down, heavy and unforgiving, turning every breath into a struggle. In the bustling markets, traders shout over the hum of voices, but the air feels like it's burning your lungs. Now, but enough to make you feel human again. This isn't a mirage. It's the work of Persian engineers who faced a challenge most of us can't even fathom. Cooling massive stone buildings without a single watt of electricity. They didn't rely on luck or prayers. They used wind, water, and a deep knowledge of the world around them, honed through centuries of observation. These engineers weren't just architects. They were survivalists. They looked at the desert's harsh winds and saw potential. When hot air passes over a wet surface, the heat doesn't just move. It's transformed into vapor and whisked away. The Persians didn't guess at this. They measured, tested, and refined their designs through generations. They built towering structures called badgers or wind catchers. This wasn't about luxury. It was about staying alive. What's incredible is that this isn't some lost art. The principles behind the Persian air cooler are as effective today as they were then. Whether you're in an off-grid cabin, a greenhouse, or an apartment during a power outage, this system can keep you cool when modern tech fails. And the best part? You don't need a palace or ancient stone. You just need a fan, some basic materials, and a willingness to think like those Persian engineers. So, let's walk through how they did it, and how you can do it too. We're not just telling a story, we're building a bridge from the past to the present. And it starts with the wind. The foundation of this cooling system is all about capturing airflow. Without air moving, there's no cooling, and without cooling, there's no survival. In ancient Persia, a tall tower with openings designed to snatch the breeze from any direction. These weren't slapped together. Every angle was calculated, every curve deliberate. The towers had to be strong enough to stand through storms and precise enough to channel air exactly where it was needed. If the airflow faltered, the whole system failed, and in the desert, failure wasn't an option. Now let's bring this to your world. You don't need a stone tower, you've got a modern equivalent, a fan. But don't just plug it in and call it a day. The Persians taught us that stability is everything. If your airflow wobbles or stalls, you're wasting energy. Imagine you're setting up your fan in a sweltering room, maybe during a summer blackout. You turn it on and hold your hand out at arm's length. Do you feel a strong, steady current? If it's weak or uneven, you've got to fix it. Mount the fan on a solid base, think a heavy table or a crate bolted down.
No stacking, no tipping.
Then, here's the trick the Persians discovered centuries before modern science caught up. Angle the fan slightly, maybe 10 degrees. This creates a spinning vortex in the air, and that vortex can boost cooling by up to 30%. Why? Because it forces the air to move faster, interacting more with whatever comes next. Test it, feel it, adjust it. In the desert, they didn't have second chances, and when the heat hits, neither will you. But once you've got that airflow humming, you're ready to take it further. Air alone isn't enough, though. You can have the strongest breeze in the world, but if the heat sneaks back in, you're right back where you started. The Persians knew this, and they didn't just build walls, they built barriers that outsmarted the sun. Their wind catchers and cooling chambers were made of thick stone, layered with clay, and sometimes mixed with animal hair for extra insulation. This wasn't about stopping the heat entirely. One weak point could let the heat flood back in, undoing all their work. They learned this through centuries of trial and error, watching how heat moved, how air flowed, and how to keep the two apart. For your build, you're not hauling stones or mixing clay, but the principle stays the same. You'll need a frame to contain your airflow, something lightweight but sturdy, think wood, styrofoam, or even heavy-duty cardboard if you're in a pinch. The key is to seal it like your life depends on it, because in a heat wave it just might. Use tape, glue, or sealant to close every gap. Imagine you're in that desert courtyard, and a single leak could turn your oasis back into an oven. Once your frame is built, test it under the fan's airflow. Hold your hand inside. Feel for dead spots where the air stalls. If you find one, adjust the frame, add a patch, make it right. The Persians called this containment, and it wasn't about comfort, it was about survival. You're building that same resilience, and it's going to carry you to the next step. Now that you've got your airflow locked in, it's time to shape it. The Persians didn't just let the wind blow through their towers. They sculpted it like artists. They used wooden panels, stone corridors, and carefully angled pathways to compress and accelerate the air. This wasn't random. Chaotic air wastes energy. Organized air cools. They discovered that narrowing the passages forced the air to speed up, like water rushing through a canyon. That speed was critical because fast-moving air interacts more with water. You'll do the same in your build. Inside your frame, install panels to guide the air. Don't make them flat. Curve them gently, like the slope of a sand dune. Think about how wind glides over a dune. Smooth and fast. Your panels should mimic that flow, directing the air without letting it swirl aimlessly. Secure every panel tightly with screws or zip ties. Loose joints mean leaks, and leaks kill cooling. Test the airflow with your hand, or, if you want to channel those Persian engineers, light a candle and watch the smoke. If the air hesitates or pools in one spot, tweak the panels. Narrow the passages slightly to speed things up. When it's right, you'll feel a steady, powerful current, what the Persians called the breath of the desert. It's not just air now. It's a force ready to transform the heat. We're getting to the heart of the system now, the part that makes this more than just a fan evaporation. The Persians knew that moving air alone wouldn't cut it. To strip the heat away, you need water, and not just any water, a surface that maximizes contact between the air and the moisture. When hot air passes over a wet surface, the heat doesn't just shift. It vanishes, carried away as water vapor. The more surface area the air touches, the more heat you steal. Double the wet area, and you could triple the cooling. It's not linear. It's exponential. The Persians used palm fibers, broken pottery, layers of wet cloth, anything that could hold moisture while letting air flow through. They placed these materials where the airflow was strongest, fed by water from rooftop cisterns or underground channels. For your version, you'll use a cooling pad, something like a damp sponge, a stack of wet cloths, or a specialized evaporative pad from a hardware store. Place it where your airflow is at its peak, right where those curved panels are pushing the air fastest. The pad needs to be damp, not dripping. Too dry and you get no cooling. Too wet and the airflow chokes. Run your fingers across it. It should feel cool, evenly moist, like it's alive. If you're using a reservoir, set it up to drip water slowly onto the pad. If you're feeling fancy, a misting system works too. The Persians spent seasons perfecting this balance, watching how water and air dance together. You'll test and adjust too, feeling for that moment when the air turns cool and soft. This is where survival begins, where the desert's heat loses its grip. But a system is only as good as its weakest point, and in the desert, weakness can be deadly. The Persians didn't build for a single summer. They built for centuries. Their wind catchers stood through sandstorms, heat waves, and the passage of time, held together by rope lashings, wooden braces, and flexible joints that could bend without breaking. They tested their designs under the worst conditions, sometimes standing beneath them during storms to ensure they'd hold. Your system needs that same strength. Once your frame, panels, even a slight movement can disrupt the airflow, and in a heat wave, that's the difference between comfort and collapse. Test it like the Persians did. Push it to its limits, because when the heat comes, it won't hold back. There's one final piece to this puzzle: water distribution. Air and evaporation are nothing without a steady supply of water. In ancient Persia, they built qanats, underground channels that carried water from distant springs to their cities. These weren't just engineering feats. They were lifelines. Without water, the cooling pads dried out, the airflow warmed up, and the system failed. Your job is to create a water delivery system that keeps your cooling pad damp without drowning it. Too little water and the cooling stops. Too much. Watch the water flow, adjust the rate. When it's right, the pad stays perfectly moist, and the air stays cool. The Persians spent seasons perfecting this. You'll find the balance with a little patience. Now let's see it all come together. Turn on your fan, let the water flow, and watch. Within minutes, you'll feel it. The temperature drops, maybe 5 degrees Fahrenheit. Then 10, sometimes even 40 if you've built it right. The air feels softer, less dry, more breathable. Check a thermometer for real-time feedback. No guesswork here. This is what the Persians felt in their courtyards 800 years ago. Relief, survival, life. This system isn't just a history lesson, it's a tool for today. In a blackout, a heat wave, or an off-grid adventure, this simple build can mean the difference between sweating through the night and breathing easy. And the best part? It's not some high-tech gadget you need to buy. It's physics, as old as the desert itself, and it's yours to wield. Why does this matter now? Because the world is changing. Heat waves are getting deadlier, power grids are faltering, and our reliance on electricity makes us vulnerable. The Persians didn't survive by hoping for the best. They survived by building with what they had. They asked, "What can we create?" Not, "What can we buy?" That knowledge is still here, waiting for you to pick it up. You don't need a palace or ancient stone. You need a fan, some water, and the memory of how people beat the heat long before air conditioners. Build it for your cabin, your greenhouse, your apartment. Scale it up, scale it down, make it your own. When the power goes out, when the heat rises, this is what will keep you going. So go build it, test it, feel that cool air on your skin, and then share it, because knowledge like this doesn't survive on its own. It lives when we pass it on. If this story lit a spark for you, hit that subscribe button and join us on Boring History for more tales that turn the past into tools for today. Drop a comment below. Have you tried building something like this? Got ideas to make it better? Let's keep the conversation going, because history isn't just about remembering, it's about doing. Thanks for watching, and I'll see you in the next one.